Assalamualaikum. My name is Yasmin from 6C4A, Group 3. And today we are going to conduct road safety audit. Firstly, we are going to introduce ourselves first. I am Amirah. Hi, and I am student AISYAH. And I am SUMAYYAH. Hi, and I am AISYAH.
Problem statement. Improving traffic management and road infrastructure have always been ongoing. Road traffic accidents and road safety concerns remain endemic, especially at intersections. The majority of intersections are huge threats to motorists, pedestrians, and cyclists due to inadequate signage, poor infrastructure design, poor traffic management system, insufficient lighting, and bad road surfaces. All these contribute to increased accident rates, jams, and general road user safety poor performance.
This is our chosen junction.
Based on geometric layout principles, there is a problem where the vehicles from the hilly parts have a limited visual in order to turn at the junction. As for the visual aids principles, the road markings and yellow box junction have completely disappeared, where it can be solved by making a routine inspection, maintenance, and also using protective top coats
Of a traffic stream at our junction. The apparatus needed for this study are radar gun, roller meter, and most importantly, wear safety vest to reduce risk of accident. Firstly, I have to stand not too close to the road to avoid causing disturbance to the drivers that can interfere the result. Next, point the radar gun direct to the vehicle that we want to take the data. Press the trigger while follow the direction of the vehicles. Take the reading and conduct this experiment for 100 samples. Tabulate the data before analyze the speed distribution. From the data obtained, produce frequency histogram to identify the most common speed at that particular area. The highest bar in the histogram indicates the common speed, which is at this junction is in the range of 20 to 24.9 km per hour, which is equal to 30 vehicles. For the arithmetic mean speed, it gives a single value that reflects the overall average speed of the vehicles. At our study location, the value is 24.3 km per hour, which is acceptable since by referring to GKR R26, the speed limit in general campus should be in the range of 20 to 30 km per hour. As a conclusion, the vehicles follow the signage, which is showing the speed limit is 25 km per hour. Landscaping in road design means the use of plants and structures along roadside to enhance the visual appeal. But excessively elaborate or colorful landscaping can distract the drivers. At our study location, the problem is trees or shrub is placed too close to the road. Hence, it can block the driver's view of road sign, intersection, or pedestrian, which is dangerous. Other than that, untrimmed trees block the street lighting. Hence, it is crucial to regularly trim the overgrown plants that block the sign distance, since stated in Pindaan 2017, at intersection, the height of trees or shrub shall not be more than 0.5 meter from the road surface.
Next, design element we observe at the intersection is alignment. Vertical alignment refers to the slope and elevation of the road, while horizontal alignment consists of a series of straight roads or tangents connected by circular curve or transitional curve. In our study area, we noticed that the slope is too steep, where from our observation show that the radius is 8 meter with the angle of 70 degree. According to Road Engineering Association of Malaysia REM, desired maximum gradient for design speed 30 km per hour is 8% and length of the critical gradient is 250, with the minimum radius is at 30 meter. For proposed solution for this issue, we recommend to install steep hill ahead sign, where to ensure all the road users alert with the condition. Next, stop sign distance or SSD. SSD is where a distance occurs at a specific speed to stop the vehicle safely when notice any warning or hazard on the road. At this study area, the issue is the driver view or sign distance is blocked by curve and signage near the crest of the hill. According to Arahan Teknik Jalan, sign distance for design speed 30 km per hour is 800 meter, while sign distance at the study area is 6 meter. We propose the solution by install warning sign or relocate the signage to avoid blocking the driver view or sign.
The next one is vulnerable road user, infrastructure, and roadside safety feeders. For the first one is pedestrian walkway. The issue is there is no designated walkway for pedestrians alongside the road. So we need to develop a continuous, clearly defined pedestrian walkway that is buffer from the main road by barriers or curbs. The next one is retaining wall. The issue is potential slope to collapse on the road surface. We need to provide a concrete retaining wall to adhere the soil slope. The retaining wall must provide lateral support and factor of safety according to the Public Works Department Malaysia. The next one is a water distribution pipe. The lack of protective border around the pipe could lead to accident involving vehicles. So, we need to develop a concrete raised border surrounding the pipe with a proper clear marking and signage. The speed bumper and zebra cross line. The issue is the junction lacks both a speed bump and a zebra crossing for pedestrian safety. We need to proper construct a speed bump with warning signage to reduce speed. Install a zebra cross line with reflective paint to improve visibility. The last one is drainage and road curb. The issue is capacity of drainage is too small and that will cause overflow. We need to improve drainage system in terms of size and gradient. The road curb has not been constructed along the roadside, so construct a road curb with sufficient height to control water flow.
The safety, comfort, and effectiveness of road users are greatly enhanced by road lighting, especially at night or in bad weather. It's particularly crucial in high-risk areas like T-junctions, intersections, pedestrian crossings, and steep bends. There are a few issues with the street lighting, and one of them is that the street lights was installed with incorrect mounting angle, which may result in uneven lighting coverage. This issue might increase accident risk and create unsafe conditions for pedestrians at night. It is recommended to adjust the mounting angle of luminaire to direct light evenly across the road surface. The second issue is that poor lighting due to surrounding big trees. They are overgrown trees with large canopies blocking the light emitted from street lamp, which reduce the effectiveness of the installed street light. It's recommended to implement a routine pruning schedule, for example, every 6 months, in collaboration with local municipal councils or landscaping units. The third issue is that there is a lane that is lack any form of illumination. Drivers may not notice the approaching junction or entrance, which might increase the risk of collision. It also poses security concerns for pedestrians or cyclists. It is recommended to install additional lighting. The state of the road surface is equally significant. A well-kept surface guarantees a smooth driving experience, lowers the chance of sliding, and gives tires enough friction. There are issues with the road surface on the studied location. The first issue is longitudinal and transverse crack. The cracks form either in the direction of traffic, longitudinal, or across the pavement, transverse, usually due to temperature variations, poor joint construction, or aging pavement. It is recommended to use rubberized bitumen or sealant to seal cracks and prevent water infiltration. The second issue is that there is a pothole. It forms when water enters through crack and poses a serious hazard to vehicles and motorcyclists, which increases accident risk and vehicle maintenance costs. It is recommended to repair drainage systems so that the water accumulation that weaken pavement structure and contribute to erosion and pothole formation can be prevented. The last issue is that there is previous patchworks on the road surface that is uneven that results in an irregular and unsafe road surface. It is recommended to remove the damaged top layer and overlay with a new one using proper compaction and mix design.